Hey everyone, welcome back. Today we're doing valid anagram in C++. For this question we're given two strings S and T, and we have to return true if T is an anagram of S and false otherwise. So our viewers, our parents might be new to this jargon anagram, but an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Pretty big, like there's a lot of words, but in the first test case we can see that if we rearrange all of the characters in anagram, we can get something like this. In this case, Nagaram is an anagram of anagram. So for the first test case, since both of them are anagrams, we will return true. And for rat and car, unfortunately in this case we cannot get car using rat, so in this case we will get false. In this case, length of S and T, the two strings, will be from 1 to 5 times 10 to the power of 4, and S and T consists of only lowercase English letters, so we do not have to worry about lowercase and uppercases. And as a little problem, what if the inputs contains Unicode characters? How will you adapt your solution to such a case? So let's quickly check what Unicode characters are. So Unicode character tables. So Unicode characters, international character encoding standard that provides a unique number for every character across languages and scripts. In short, it's like all possible types of characters, if I'm not mistaken. So in this case, that's pretty much, I think that's okay. Okay, let's take a look at the Unicode characters just to be sure we understand the problem. So we have now characters, device, paddings, characters. We have many types of characters, so we have even Latin, but if I'm not mistaken, this is fine. So a very naive approach first is to, there's a couple of scenarios for this. I guess I should make it clear. So for the first scenario, length of S and T are different. So in this case, this is a pretty simple scenario. So let's just return false. For scenario 2, length of S and T are the same, but they are not anagrams. For scenario 3, it's the same scenario, but they are anagrams. So for the first scenario, we can quickly check if the length of S is not equals to length of T. Then what we can do is we can return false, just like this. So two strings S and T of different lengths will never be anagrams. So this would handle scenario 1. For the second scenario and the third scenario, one naive approach would be to use a hash map to keep track of all characters in S. And afterwards, we will iterate all characters in T, and we will start subtracting the characters inside here. So because S and T are guaranteed to be the same characters, within this loop, we will either complete the full iteration and have this unordered map having 0 counts for all characters, or we will terminate midway. So let's quickly do that by importing unordered map, and let's create an unordered map. So in this case, this would be, if I'm not mistaken, a character to an int, and this would be S count. And for character current char in S, we will do S count char plus plus. Actually, let's see. If I'm mistaken, in C++, we can just increment the current char like this. So that's pretty convenient, but I'm frankly not too sure. I'll have to check this out. The next thing is to iterate all characters in T, and what we will do is if scount find current char is equals to scount.n, in other words, this character doesn't exist in this hash map, then we return false. So if character in T doesn't appear in S, this is not an anagram. Else, if scount find current char is equals to 0, then what this means is if there are not enough characters in S for T, they are not anagrams. So we return false as well. Else, we would decrement the count of this current character like this. So I might be a little wrong. I'm not too sure if this is allowed. I mean, to be safe, we can, if under technical interview conditions you're unsure, one tactic is just to be safe and just use this. Just do this safe check. So if this scount for current char is equals to scount.n, in other words, if this current char is not in the hash map yet, initialize it to 1. So this will be scount current char equals to 1, else scount current char plus plus. So that's pretty much it. So now at the end of this check, if we do not terminate within this loop, then we can return true. So in summary, what we're doing is we are using scount to keep track of characters in S, and for every character in T, we subtract it from scount. If we can't subtract, we return the strings are not anagrams. So at this point, if we pass the check, the full iteration, they are anagrams. So that's pretty much it. Let's quickly take a look for typos, and I guess what other better way to do that by going through a test case. This would also make it clear to our spectators, our technical interviewers, on how this works. So in this case, S and T, since they are both 7 equals to 7, this will be true, so we will skip it. Now for the first character in S, this is A. And because A is not inside scount, scount will have A equals to 1. Afterwards, we move on to the next one, we get N, and we put it in. For the third character, we increment it. Next we'll have G, then we have R, we have A as well, again, and finally the final character M. So our scount dictionary will look something like this after this iteration. Now we will start iterating all characters in T. So now the first character in T is N. So current char equals to N. So we will decrement it. This will become 0. Now we will check for A. We will decrement this because we'll hit this branch here. Now we will go on to G. We will decrement the G. Now let's go on to the fourth character A. We will decrement A again. Now we get 0. Let's go on to R. We'll decrement R. We go A. Did I do some tracing? Did I do the tracing correctly? But in this case, A should not be subtracted, I guess. I mean, A should be 0 by now. So finally, for the final character M, we'll decrement it and we should get an empty unordered map like this. So this looks fine. Let's run this against the sample test cases. Pardon me for the incorrect tracing. I probably subtracted A prematurely in one of the iterations, and that's why we tripped a little bit during the tracing. But because we know that these two are definitely anagrams, I just proceeded with the tracing anyway, since I know that they are right. So let's submit this, and there we go. This works. So for the time complexity in this case, because we do a full iteration here in S and another full iteration in T, in this case N would be the length of S and T when they are equal length. So in the worst case, worst case happens when S and T are anagrams. Because when S and T are anagrams, we do the full iteration across these two for loops over here. So the time complexity in this case will be O(n). We do two full iterations, sorry. So, but if we remove the constants in the time complexity analysis, we'll get O(n). For space complexity, worst case happens when S and T are the same length, and we will end up storing every single character in S inside this unordered map. So in this case, this will be O(n) as well. So previously we were wondering if we can just increment the count of char like this. So let's quickly check if this works. Let's remove the guard to check whether if the current character exists in unordered map first, and let's see if this still works. Yeah, it works actually. So I remembered vividly that C++ allows us to do this, so this is just to reinforce my existing understanding that we can just increment a key's count just by doing ++. And under the hood, this unordered map is smart to initialize this to 0 and increment it. So that's pretty cool. Like, it saves a lot of time. Let's see. Do we get a key error if we do this? So let me run this to see if this unordered map will be smart to just check if the count is equals to 0. And it seems it does. Like it's smart enough to do that. So we don't have to do the check for current character inside S count. So this is great. So I learned two specific things today tactically. The first thing is we do not have to do a check for whether if the current character exists in the hash map. And similarly in this case, like if you pass in a current character into S count, it works. Like it will just default this current character's key to 0 if it doesn't exist. So this is pretty cool. It's pretty useful feature of C++. In Python, we have probably gotten a key error, and same for Java if I'm not mistaken. So that's it for this practice. I find this pretty helpful, and I hope it was for you as well. So if you like this, I hope to see you in the next video.